Today's lesson is going to be on the area of a regular polygon. Okay, so we talked about regular, trying to remember what unit it was, Unit 7. Unit 7, we talked about what regular was. Regular polygon is a polygon with all the sides equal and all of the angles are equal. And we calculated those angles inside, the interior angles, and outside, the exterior angles. Okay, so now we're dealing with the area, the space inside. Okay, so we have area is equal to 1/2 P times A. So let's take a look at that. The A is equal to apothem. Yes, that's the pronunciation, apothem. The length from the center of the polygon that is perpendicular to the side. Okay, so the apothem stems from the center of the polygon perpendicular to the side of the polygon. Okay, P is for perimeter. So we're finding the distance all the way around the polygon. Okay, so those are the parts of the formula, and it's 1/2 perimeter times apothem. So let's get into some examples. Let me write the formula. Area is equal to 1/2 the perimeter times the apothem. Okay, so in example 1, this is pretty straightforward. They give us our apothem. That's going to be 15. And then we're going to use 12 to calculate our perimeter. Okay, so our perimeter is got a side length of 12, and they're all the same length. So we have 1, 2, 3, 4, 5. So that gives us a perimeter of 60 units. And now we can plug them into our formula. The area is equal to 1/2 the apothem, which is 15, times the perimeter, which is 60. Okay, so let's see if I can bring up my calculator here. And we can type that in, although you can't see the... All right, so we have 1/2, I'm going to put 0.5 times 15 times 60. That gives me 450. So use your calculator. It's equal to 450 units squared. 450 units squared. Okay, number 2 is pretty straightforward as well. Although you're probably looking at the radical going, I don't like that, but that's okay. We'll get through it. So again, our apothem, that's the 2 square root of 3 over 3. And then we want our perimeter. So there's 3 sides. It's a triangle. Each side is 10. There's 3 of them. So our perimeter is 30 units. Okay, so now to find our area, we're going to take 1/2 the apothem, 2 square root of 3 over 3, and then times our perimeter, 30. Okay, well, first thing I'm going to do is I see 3 goes into 30, so I'm going to simplify that. That goes down to 10. Then I see 2 goes into 10, so I'm going to simplify that, and now I get a 5. So now I have nothing left in the bottom, so all of my denominators canceled out with the 30. And I have 1 times 2 square root of 3 times 5. Okay, that gives me 10 square root of 3. And that's going to be units squared. So that's my area, 10 square root of 3 units squared. Okay, so it's not as bad as you think. Some of them you can multiply it all the way out if you want to. That would give us 60 square root of 3 over 6. And then you can see the 60 divided by 6 does equal the 10. Okay, so this is what's called cross-reducing. When I took the 3 and divided it by 30 and got 10, and took the 2 into 10 and got 5. Okay. Our next example, see now we don't have the apothem. we need to identify it. So I'm going to draw in the apothem because that's the part that's blue. I'm going to go ahead and do it for both examples. We need the apothem. Okay, so here we might have to use some trig. Because we have a triangle, this is going to be 120 degrees at the center from radius to radius. That's going to be 120. I could also view this as 60. Remember, each interior angle of an equilateral triangle is 60 degrees, and the radius here would split it. So that would make it a 30-degree triangle. And this would make this a 60-degree. So here I actually have a special right triangle. So I'm going to use my 30, 60, 90 graphic organizer, and we did learn this. It's going to be x square root of 3, and 2x. I'm given the hypotenuse side, so that goes under here, and I need the apothem side. The apothem side is the 30 side, so I need this side, so I really don't need this one. So now, because we probably need a refresher on how to use our special right triangles, now that I know that my 90-degree side is 6 and 6 is equal to 2x, so I set those equal to each other. They're in the same ratio. So we're going to divide by 2, and my x is equal to 3. That means this piece equals to 3, and that means my apothem is equal to 3. Okay, now I need my perimeter. Well, each side is 6 square root of 3, and I have 3 sides. That's going to give me 18 square root of 3 for my perimeter. That'll be units. And now I'm ready for the formula. So the area is equal to, and let me write it up here, area is equal to 1/2 the perimeter times the apothem. My perimeter is 18 square root of 3. Let me get the half in there first. 1/2 times 18 square root of 3 times my apothem, which is 3. Okay, well, I notice the 2 goes into 18 for 9. That gets rid of my half. And I have 9 square root of 3 times 3, which is 27 square root of 3. That's going to be my units squared. And that's going to be my area. Okay. Now, here I have a hexagon. Each angle in a hexagon was 120 degrees. That means this radius here is splitting that in half, so that's going to make it a 60-degree angle, which is going to make this one a 30-degree angle. So I again have a 30, 60, 90 triangle. So 30, 60, 90. You can always go back and look at these graphic organizers. X square root of 3 and 2x. And the 10 is across the 90, so that goes underneath my 90, and my apothem again is my 60-degree side this time, so I don't need this one. I need to calculate the 60-degree side. So 2x equals 10. So if I divide by 2, I get my x is equal to 5. That's normally what would go here. I would put 5 here. However, I don't need that one. I need the 60-degree side. So I'm going to substitute that in. So it's going to be 5 square root of 3. So my apothem is 5 square root of 3. Now my perimeter, I have a side length of 10, and I have 6 sides, so that gives me a perimeter of 60 units. Now I'm ready for my area. Area is equal to 1/2. My perimeter is 60. My apothem is 5 square root of 3. Half of 60 is 30. So I get 30 times 5 square root of 3. And that leaves me with 150 square root of 3 units squared. 150 units 150 square root of 3 units squared. Okay, we have one more example. This time, we're just given the radius. So we're not given any side length. So I am going to need that apothem, so I'm going to draw that down. Now this is a pentagon, and the sum of the angles in a pentagon were 108. 108. So if this splits that in half, 108 divided by 2, that gives me 54. So that is a 54-degree angle. Okay, so that's not a 30, 60, 90. That's not a 45, 45, 90. So when it's not one of those, then we have to use trig. And we're going to use trig to find both the apothem and the side length. Okay, so that means I need to label my sides. Okay, so I know my 8 is the hypotenuse. That means my apothem side is the opposite side. And that means my adjacent side is going to be the side length. So now I need to use trig, and I want to find the apothem. So the apothem is opposite over hypotenuse. And if you'll remember, we have SOHCAHTOA. So we have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Since I need opposite and hypotenuse, I'm going to set up a sine. So now I have sine of 54 degrees equals the opposite side, which is what I need, over 8. I'm going to multiply by 8 on both sides. That cancels out, so I need the 8 sine of 54 for the opposite side. Okay, so let's see. I need 8 sine. Oop, this is doing something different. Okay, so I guess I need to do 54 sine. Need my equal sign. Okay. And then I needed to multiply, let me see. This doesn't seem right to me. Okay, 54 sine, there we go, times 8. Okay, so that gives me a 6.47. 6.47, and am I in degree mode or radian mode? Degree mode. Okay, got to check that too. So let me try that one more time. Actually, remember I said do the sine of 30 to check it? Okay, so now I'm in degree mode for sure. So let's do 54 sine. Times 8. 6.47. All right, so 6.47, that's equal my opposite side, which is my apothem. Okay, now I need to find this side. I need to find the adjacent side. So the adjacent side is going to be cosine because it's adjacent over hypotenuse. So now I'm going to set up cosine 54 equals adjacent over 8. So I'm going to get 8 cosine of 54 because I multiply both sides by 8. And that equals my adjacent side. So 54 cosine times 8. That's going to give me 4.7. So my adjacent side is 4.7. Okay, so my